to complete for today. This is Unit 1, Lesson 10, U1L10. So go to the Canvas homepage or to the look underneath assignments, but either one you're looking for tasks for U1L10. Today, I just want to quickly review the homework. I threw a lot of moon stuff at you, drawing the phases of the moon, so you need to submit a drawing of that based on the video, post about the moon landings, and make a little flip grid about observing the phases of the moon. Did anyone have any questions about those assignments or needed help on any of those?
Mr. Haight?
Yeah.
Jake texted me and his computer's being annoying, so he's restarting it.
Okay, yeah, that's fine. Thank you for letting me know. So from what I can see, this is C period. I'm just looking at my submissions here. Drawing phases of the moon is looking good. Few of you I still need it from: Sloan, Harry, Clarence, Valen, Thomas, and Summer. I'm not seeing uploads from you yet, so upload your drawings as soon as you can. Same with, oh, weird, why do I have that in there twice?
Wait, Mr. Haight?
Yeah.
Wait, was it a flip grid we had to do, or was it just take a picture of it?
Yeah, just take a picture of it. Mm-hmm. Yeah, okay, good. Yeah, I'm seeing two in here for some reason, so I gotta figure out what's going on with that. But yes, so Thomas, I do have yours. Whereas the flip grid, I'll go take a look at that too. But again, if flip grid's giving you any trouble, just feel free to email me the video as well. And just something simple to see the actual phases of the moon. How many of you kind of realize that the same side of the moon always faces us? How many of you knew that already? I did not. I'm raising my hand, but I always find that really fascinating. And when you hear the dark side and the light side of the moon, it literally is that Earth's orbit, the moon's orbit matches Earth's, and so we're always seeing the same side of it. And that kind of flip grid demonstration was meant to show you that, as well as why we see the differences in the light. I always thought it was Earth's shadow on the moon, but it's actually just the light from the sun on the spherical surface. Okay, then for the do now, we're going to do a quick little speed meeting. We'll do 2 rounds. I'll throw you into random breakout rooms. As usual, say hi, check in, but then I want you to share your answer to the questions posted for each round. The first round, I'll post it in the chat, but basically it's just after doing some research on the moon landings, I saw some very entertaining posts about whether the moon landings were faked or not. The question I would like you to answer in this first round is, my chat not opening, there we go. I'll chat to everyone. There we go. After doing some research on the moon landings and reading at least one classmate's post, do you think the moon landings were faked or real, and what is the key evidence that convinced you? We'll come back together in 3 minutes. Rooms are open, go for it. All right, we'll let the last few people trickle in. Again, very entertaining seeing a lot of your posts. So right here and now, how many of you were somewhat maybe convinced a little bit that the moon landings might have been faked, or that there's some merit to that conspiracy theory? Jake's all over it. Nathan, maybe a little bit.
100%.
Nice. Yes, well, again, it's all on what you're reading. Again, I always kind of look towards the conspiracy theory idea, and just when you look at how many people were involved in all of this stuff, thousands of engineers and everything, that would have been hard to coordinate a secret like that. But Jake, I don't want to quell you completely. So.
Well, they were all working on the lasers to film it.
Ah, okay, yeah, exactly. And they were all paid off. They were just paid.
Yeah.
That's where all the money went. The billions of dollars was to pay for everyone's silence.
Yeah.
So, yeah, maybe. Anyway, yeah, who knows? Maybe a future opportunity could be go to the moon with you people. SpaceX is going to be making leaps and bounds in that regard. So I do find it weird that we haven't sent any other humans up there since the 1960s. So that's another weird thing. But okay, next round is going to be a little silly. I'm going to recreate the same rooms. same deal. Say hi, introduce yourselves, check in. But then the question is not so science related this time. The next question I just posted in the chat is, if you could hang out with any cartoon character, Disney, anime, Pixar, Cartoon Network, Adult Swim, Looney Tunes, whatever, who would you choose and why? I'm going to give you about 30 seconds to think about it. I'll open up the breakout rooms for you to share your answers. Okay, breakout rooms are open. We'll come together in 3 minutes. All right. So, Thomas, who is your cartoon character of choice?
Uncle Ruckus from the Boondocks.
Oh, yeah?
Yeah.
Nice. Rowdy character.
Yeah.
Harmony, how about you?
I said Daffy Duck from Looney Tunes.
Nice. That would be an energetic character to hang out with, that's for sure. Joseph, who is your character of choice?
I say JoJo from the JoJo Bizarre Adventure because the name is similar.
Nice. Harry, how about you?
Season 4 Eren Yeager from Attack on Titan.
Oh, nice. Yes, tough character. Jake?
Shrek, absolutely.
Shrek? Nice.
Yes. A man of the people.
Indeed, an ogre of the people.
Yeah.
Valen?
I said Finn from Adventure Time.
Nice. Yeah, that character's come up in a few of my other classes too. Bianca?
We couldn't really pick, but we talked about Caillou and then Clarence, like from a show called Clarence. That's what Clarence said.
Okay, haven't heard of it, but cool. Ryder, how about you?
I would have to say Phineas and Ferb, because they do cool stuff.
Nice. Yes, science inventions.
Yeah.
Augie?
I couldn't think of it, and it's mainly just because most of the characters that I like aren't very nice people, like Batman. I mean, I wouldn't really want to hang around him.
Might be fun to hang around Bruce Wayne, though. Might be a good person to know. Mm-hmm. Abby?
I said Big Mouth.
Oh, nice. Yeah, well, you're all around that age, right? That's why you're all going through the same stuff. Nathan?
I couldn't really think of one, to be honest.
That's okay. Yeah, not everyone's into the cartoon stuff. So, Clarence?
Okay, I don't know how nobody knows this show, but it's like...
Oh, is it like the little kid?
Yes, it is! Oh!
The little boy that like runs around.
Exactly! Everybody's super... Okay, because when everybody first meets me, they're like, oh, are you named after the show? And then I'm always like, no, the show's named after me. And like, I don't know why, but like, I refused to watch it like out of spite. And then like one day I was like, oh, I gotta do it. I gotta see what the hype is about. And it's so funny and so weird. And his friend's name, so I would hang out with Clarence and he has like 2 of his friends, and it's like Sumo and Jeff, and Sumo is just like insane. And like I was like, ugh, I'd hang out with them. Like definitely.
Nice.
It's like my favorite cartoon.
I remember that.
Summer, how about you?
I said that I would hang out with SpongeBob characters.
Nice. Yes, they would be fun. And Sloan?
The people from Regular Show.
Say it again?
Regular Show.
All right. Yeah, I haven't heard of it. Yeah, maybe not the most appropriate example, but I thought it'd always be fun to hang out with Rick from Rick and Morty. But that's also just because I'm not a science person, and alternate dimensions sounds kind of fun. So great. All right. Well, thanks a lot for sharing. Without further ado, we have one last solar system presentation to get through, and then we have concluded. Jake and Valen are going to talk to us today about asteroids, comets, and dwarf planets, and whatever else.
Yeah, we are.
You guys ready?
Yeah, sure.
All right. How do you want to do this? Does one of you want to share the screen? Do you want me to pull it up?
I'll share.
Okay, I'll make you a co-host. So everyone else, as usual, this is the last round of notes. So please grab a notebook or a piece of paper. The title is, well, we'll see it on their slides, but it should be something along the lines
Let me
of
just have it load up.
Asteroids, Comets, and Dwarf Planets by Jake and Valen.
Okay, see that, right?
There we go, yeah.
Okay. It's dwarf planets, asteroids, and comets.
Valen, you feeling ready to go?
Yep.
Everyone got notes ready?
Take time there. Okay.
All right, let's do it.
Dwarf planets. Dwarf planets are not classified as regular planets because they don't accumulate matter in their orbit. Like they don't have moons or anything orbiting them. The best known dwarf planet is Pluto, which in 2006 was called a planet. There are five dwarf planets officially noted as dwarf planets: Ceres, Pluto, Makemake, and
I like that one a lot.
Yeah.
And Huame and Eris. All except Ceres are located in the Kuiper Belt.
We'll talk about that.
Yeah. Kuiper Belt's how it's pronounced.
Kuiper Belt.
So, and if you go back, that image is great. I love it. I know it looks fake, but we actually had a really close flyby to Pluto. That's a real image. It's been colored in a bit, but it's pretty cool.
Yeah, I find that so cool.
Size of dwarf planets. Eris, some believe it is the Kuiper Belt, but is sometimes categorized as past the Kuiper Belt, is the largest dwarf planet, and Ceres, which is in the asteroid belt, is the smallest. Though there are only five dwarf planets called this name, there may be 50 in our solar system.
There's only like 5 categorized officially as dwarf planets, but there's ranging numbers. So the Kuiper Belt, what is it? It's kind of an icy region of space that's it circles around like kind of in the orbit donut shape, if you would, and it goes out almost 50 astronomical units from the sun, which is, you can see there, it's a lot of miles that do not want to try with all those zeros, but it's a far commute. And so 4 of the 5 official dwarf planets are in the Kuiper Belt. Ceres is in the asteroid belt, and it is believed that some moons originated from here, like Neptune's Triton, which we learned about in the outer planets, and Saturn's Phoebe came from here. And many comets are believed to come from here, or the Oort cloud, which is this. So the Oort cloud, unlike the planets in the Kuiper Belt, which are kind of that donut orbit around the sun, it's kind of like a thick bubble that surrounds the whole solar system almost. And its inner regions, just the inner regions, can be as far away as 5,000 astronomical units, which is quite a lot because we were just talking about how far away 50 is. But it's believed that many comets that are long distance, like taking a while to travel, extremely slow, are believed to come from here because that's typically the time range between them.
It's kind of like the outermost layer of our solar system almost.
Yeah.
Comets. Comets are the frozen contents from when the solar system was formed. They ever since are now, or they're just balls of gas, rock, and dust that travel the solar system. When these frozen comets near the sun, they could begin to rapidly heat up and leave a burning trail of their gas and ice, which is the famous comet tails that we see. There are likely billions of comets that we only know of 3,679, which got close enough for us to see. Sometimes these comets take centuries to pass through our solar system. In 2014, one from the Oort cloud passed Mars and isn't expected to pass again until around 700,000 years from now. Asteroids. Asteroids are small rocky matter which orbits the sun. They're typically found within the Jupiter regions of the asteroid belt. The asteroid belt is a large region between Mars and Jupiter. This is where many asteroids we know of are from. In the future, we may start mining on asteroids. These rocks may have valuable resources, and whoever harvests them could make trillions.
Yeah, there's that whole idea of like what's on there, and you can get like a satellite kind of mine that resource and then get back. That's where a lot of like economists think that the first trillionaires are going to be coming out of asteroid mining.
It might not only be things like metals, but things like water, like more fresh water, which a lot of people don't think about. But yeah,
especially as we increase in population. But meteors are small masses that enter Earth's atmosphere and burn up. That's sometimes that streak of light, which is what we think of a shooting star being. Though if the meteor does survive the heat of going through the atmosphere, which you kind of see, like when you see like video of like a space shuttle or something coming back into atmosphere, and then you see that immense heat going around it in some like movies, that's kind of what happens when a meteor goes into the atmosphere. But when it survives that, it becomes a meteorite. Meteorites can vary in size, sometimes being the size of countries, but mostly microscopic. And sometimes when you put a magnet to the ground in certain areas, you'll get like tiny little pieces of iron. And those sometimes most likely come from tiny microscopic meteorites entering Earth that got past. Just like they probably were bigger, but kind of break down. Okay, meteorites that have hit Earth. So in 1908, something called the, forgive my pronunciation here, Tunguska event, I think that's right.
Yeah.
Was a meteorite that was about 330 feet in size, which is very big. He hit eastern Siberia in the, Tunguska region, which ended up flattening 830 square miles of forest, which was 80 million trees, they believe. So you can see that on right here, kind of on the bottom. That's not the best image, but you can see how it's kind of flattened. And there's no actual impact crater because it burned up kind of right before, and then it flattened them. It's the largest meteorite to hit Earth in our recorded history that we know of, like that we've documented that humans were around. And in 2013, the Chelyabinsk meteorite hit the Chelyabinsk Oblast in Russia, which is like a province. And the meteors seem to hit Russia for some reason. I guess it's a big area to hit. But it blew up in the air above the oblast, and the explosion was literally brighter than the sun. We'll show a video in a second. And then prehistorically, the largest meteorite ever known was the Chicxulub meteorite, which hit the Yucatan Peninsula, and that would have been 50 miles in size compared to like the 330 feet of the Tunguska one. So it's pretty different. And that is the event that is most likely believed to wipe out the dinosaurs. So that's just the impact of what they could do. Here, I want to show the video of just it kind of burning up in the air on a Russian dash cam here. Let me see here.
Yeah, this is famous footage. I've seen this before.
That's crazy. You see it coming from top left. So you see it kind of burn up in the air right there, right before it hits. But what I'll show you now is we're just gonna kind of flip-flop through here. You'll hear some Russians. This is kind of, this is the damage that caused by like the sonic You can see like windows crashing. You can see it's kind of there's a streak left.
It blew out windows in buildings and really, really loud sound too that was delayed. Yeah,
I mean
it's great.
And so, thank you. There's some of our works cited, and yeah,
nice.
Does anyone have any questions? All right.
That's awesome. Yeah, some people are obsessed about collecting these things too, the meteorites. And did you see the differences in the terminology? So like Again,
Yeah,
I can never get this right. That it's a meteor when it's in space.
it's a meteor when it's in space, and it's an asteroid when it's circling the sun.
Yep.
It's a meteor when it's in space and going into our orbit. But when it passes our orbit, it's a meteorite.
Meteorite, and then when it hits the Earth, right, what's left over is technically a meteor.
Yeah.
It's so weird the way they distinguish the
sometimes
names.
you hear them being used in different contexts too, which just adds to the confusion. But
yeah, I gotta say, one of in learning about comets and asteroids and the asteroid belt, and you guys kind of got at this, but one of my biggest disappointments is after watching movies, in reality, the asteroid belt is not very dense at all. It's a bunch of little tiny rocks that are all spaced out. So if you've ever seen those scenes in Star Wars or other movies where spaceships are flying between giant rocks that are all dense together, that's not what it's like. It's more like a bunch of tiny rocks and sand and gravel that are all spaced out everywhere, which I find kind of sad. But anyway, it's just another one of those weird misconceptions that people don't usually think about. So great. All right, that concludes our solar system project. So what I need to make sure is that everyone has submitted questions. I've been looking at the Google form, and it looks like every group has. So I've got 7 multiple choice and 7 free response questions based on solar system. Those will be included in the Unit 1 test, along with a couple more things from me. I do reserve the right to edit or adjust questions as needed. My experience and from what I can see looking through, you guys post some hard questions, man. You're like mean to your classmates. Get some really hard ones. So I might try to make them a little more fair, reasonable in a few cases, but otherwise they're looking pretty good. Chief thing now is to please make sure that you have submitted all of the notes photos for topics 1 through 7. Again, looking like I've got most of the ones in for topics 5 and 6, missing a few for topic 6. Like Clarence, I need your topic 5 notes. Thomas and Ryder, I need your topic 6 notes. So just upload a photo to those assignments as soon as you can, and then please make sure everyone gets number 7 done. I did look at the Flipgrid as well, and I'm only seeing 7 responses to the Moon Flipgrid, which means about half of you have done it. So whoever hasn't gotten that done yet, please just take a short video. All you need is just a light source in a room and something round. It could be a piece of fruit or whatever. Okay, so now that we are done with the solar system project, anyone know what's going to happen the next time we meet as a class?
Test.
We are taking the Unit 1 test. This is your first assessment in Science 2, so I want to take just a quick moment to walk through what this is going to be like. You might see that the quiz is actually already posted on Canvas, though it isn't like available to take yet. There aren't any questions in it. But you can go and look for that underneath quizzes. But the point is, I have also posted on the bottom of the tasks to complete list here a study guide and review slides. And I will do my best to always provide these before an assessment. The study guide is going to kind of walk you through everything we've covered so far in this first unit and what you should study. So the goal for the test is going to be about 75 to 100 points. Remember, though, the tests are only worth 25% of the grade, same as homework. It's labs and activities that are more valuable. But it's going to be based on 4 things: Hewitt Chapter 29.7, Hewitt 28.1, the rest of Hewitt Chapter 28, which was the solar system stuff, and then a little bit of gravity that we did in Hewitt Chapter 5. So I've got digital links to all those readings there, and then I have a little breakdown here of the different topics that were within each of these and sort of what you should be comfortable with heading into the test. Now, this is open notes, which means I'm not going to try to control anything about what you view or what you can't view. You can have your notes open, you can have review slides open, you can use Google, it doesn't matter to me. I often tend not to set time limits. It's ideal if you could have it done by the end of our class meeting, right? We'll do a little review, then we'll start the test, and then ideally you're done by the end of class. But if you need extra time or anything like that, that will also be available to you. The review slides are just a collection of slides I used in class. I also have links to the videos of me going through these, so you can access those easily. But it's just going back to when we first started, talking about Hubble and evidence of the Big Bang, and then moving through the solar system and onwards. You can also access all the solar system project slides on that discussion board that we shared them on. So all of that is available to you to prepare for the test, which we will have the next time we meet. Any questions on how the assessment's going to work or how to prepare? All right. Then I wanted to use the remaining class time to go through one more gravity activity. We have covered a little bit of Newton's universal law of gravitation, and I just want to kind of hammer this home of the relationship between mass and distance. This is kind of the first basic thing to understand about gravity. We're going to take it to the next level and do some math and some more simulations with it. After the test, we're going to get into kind of a gravity and orbit unit. But for now, I just want to keep it simple. So on the tasks to complete list, this is step number 5. You're going to be using a PhET simulator, which I'm sure many of you have probably used before. But it's a free online simulation. This is what the Gravity PhET lab will look like. You'll notice that you're essentially controlling distance by grabbing and moving these guys here. They make some funny noises. And you can change the mass here. And just note that it is in kilograms. Usually it's in, you'll see, you might have a different link that puts it in billions. This actually might be a different version than what I will have you guys use. Let me see. There's kind of a more direct one. Might be this one actually. Because that one has the force measurements and kind of really ridiculous numbers, which is not ideal to work with. It's nicer when it's in newtons. Yeah. Okay. There's a version that has it in billions. Anyway, I'm sure that's what, you'll have the proper link to it. But anyway, you're playing with the mass, playing with the distance, and answering some questions on a quiz that is right there at the bottom of the tasks to complete list, titled the Gravity Force Lab PhET Quiz. I'm going to time for, let's say 15 minutes to kind of work through that, though we'll probably be done in well, let's go ahead and time for 10 minutes and just see how we're doing at that point. And then we'll come back together for a quick review. I'll be here if you have any questions. Go for it.